Good morning, one and all. I am Dr. Ramya Swetha, Assistant Professor, Department of Civil Engineering from Institute of Aeronautical Engineering. As a part of analysis of structures, we are talking about our topic title is Radial Shear Force. So today we are going to understand the radial shear force. So under the various kind of structures based on their shape, whether it is parabolic, whether it is circular, whether it is 2-hinged, 3-hinged, based on the number of supports and how the loading conditions are we are getting from the outside are loading conditions based on the various soil conditions of the structure. Heavy structures are maybe moving on the particular structure. Arch, especially in arch, we are talking about this arch topic. So in this, how this radial shear force plays a role, what is meant by radial shear force, how it plays a role, and how it adopt the other forces involved in this particular structure. So today we are going to understand all these parameters. Here these are the course outcomes. In this radial shear force, the theorem is involved, that is the Itte's theorem. So in this Itte's theorem, we are talking about the radial shear force. So it is, we have n different types of condition. Those are normal thrust and radial shear force. In this, already we know about this normal thrust is nothing but the, whenever the arch is there, so it is normal force, normal to that arch force, that is nothing but the normal. So normal of the force which is perpendicular to this is nothing but the radial shear force. Perpendicular force which is acting to the normal thrust through the point where the arch is there, such type is known as the radial shear force. So here, coming to this particular theorem, here whenever we have different types of loads we are applying for this arch. So in this arch, so it is the actual arch. Once we are applying the various loading condition, whether it is point load, concentrated load, uniformly distributed load, whatever it may be, we are applying various different of force load conditions we are applying. According to that, so it is going to deform or it is going to react because of the, based on the forces, how they are coming from, depending upon the shape and support and which type of material we are used for these. All these parameters are influenced how it is react. As per that, so this shear force and bending moment we are consider as parameters. So in any section we consider, somewhere we are going to consider this. So once we consider this, whenever we are consider any section from anywhere, so till that the bending moment of an arch which is proportional to the vertical interruption between the theoretical arch and the actual arch. So here once we applied this force, these load conditions and whatever the various load condition, we are going to draw about their bending moment. So this is nothing but the actual arch, and once we form this based on the bending moment, so that is nothing but the theoretical arch or linear arch, whether it is theoretical arch or linear arch, those vertical ordinate, those vertical ordinate is proportional to this bending moment. Such is known as the statement of this Itte's theorem. So here, whenever the bending moment at any section of an arch which is proportional to the vertical interruption between these actual arch and the theoretical arch, this is nothing but this linear arch is nothing but the theoretical arch and the central line of the actual arch. This is the statement of this Itte's theorem. So here what we consider from two supports which we consider, these are the reactions along with the vertical reactions, whether it is vertical reactions and horizontal reactions we may consider at the point. So somewhere we are considering this is the baseline. From here to there, this vertical ordinate is nothing but this vertical intercept between these actual arch and this theoretical arch. Otherwise, this is nothing but this theoretical arch is nothing but the linear arch, which we are called as per the Hiddes theorem. So this statement is nothing but the involved in this radial shear force. Whenever the normal thrust is perpendicular to that shear force is there, such is nothing but the radial shear force. This radial shear force is notation is R, and this normal thrust is nothing but N. These are the parameters which are involved in this thing. Now we are understanding how these normal thrust and radial shear are involved in this. So once we consider these rectangle these parabolic arch which has the symmetrical condition, both are having in symmetrical conditions. In this we are going to apply we know these vertical reactions. Sometimes the vertical reaction in terms of V or in terms of R, and horizontal reactions. H at that particular point, whether it is at A and whether it is at B, depends upon the where that particular point we are consider. So we have to understand those. So whenever the parabolic arch is there, their direction normal to the parameter, normal to that is nothing but the normal thrust. So perpendicular to this normal is nothing but the radial shear force. Here we are considering somewhere of these, somewhere that is section that is nothing but the X on a arch. Q is the inclination of this tangent. Q is nothing but the inclination of this tangent. So we know that Q is nothing but the inclination of the tangent X, where we consider that the section. So if H is the horizontal thrust and V is the vertical shear at that particular section where we consider that is X. So from the free body of this right hand side of the arch, it is clear that the V and H will have normal and radial components given like this. So N is equal to normal thrust is equal to horizontal thrust multiplied by cos theta plus vertical shear sin theta, and move on to this radial shear that is equal to V cos theta minus H sin theta. These are the equations which we know about this normal thrust. N is nothing but the normal thrust. R is nothing but the radial shear. And here also what is this theta we will see in our next slide. That is, so here what we understand. So whenever the symmetrical condition, this is nothing but in symmetrical condition with two hinges are there, those are two, it is nothing but the two hinged arch. So whenever the one more hinge at crown, that is nothing but the three hinged arch, it is symmetrical, and from here to here the length is nothing but the length of the span. So that is the length of the span. So these are the springing, these are the hinged at the supports, and from here to at midpoint of the arch to this base is nothing but the rise. Whenever the rise, the highest point is nothing but the crown. These are the various parameters which are involved in this particular thing. So in this two hinged arch, for a symmetrical parabolic arch, as per our previous studies, we know this y is equal to 4h by L square x L minus x. Here where yc r is nothing but this is the where at the y at the center, that is nothing but the r is nothing but the rise of the arch. Here this yc at the center point, otherwise this y, it depends upon the where it is there somewhere. So it is depends upon this. From here this is nothing but the rise. So at C. So at crown, so that is nothing but that is equal to this R, that is nothing but the rise of the arch. And L is nothing but the length of the arch or length of the span between two supports as per the previous one. Support. So we know in this we have and different types of forces are involved. Those are forces along with the x-axis, forces which are involved in horizontal axis, and f of y is nothing but the forces which are involved on this vertical axis. So here this horizontal axis which we are involved in this, those are nothing but the shear forces in the arch, and along this forces vertical axis those are involved is nothing but the thrust. So like this we are going to understand these things. So now as per this we know different types of internal forces those are involved. Those are forces along x-axis, forces along y-axis, and also the movements which are involved in that a particular arch as per the loading conditions we are going to understand. Here the normal thrust along the x section we are talking about that. So that is nothing but the nx is equal to v sin theta plus h cos theta. And radial shear at x, so radial shear at x is equal to vx sin theta minus h cos theta. And the slope, here the slope is nothing but the, coming to the slope of the arch, that is nothing but the theta. So here the theta is equal to tan inverse 4h by L square L minus 2x. Here where L is the length of the arch, x is the where we are consider this particular section, h is nothing but the how much height it is there. So these are the parameters which are involved in this. Find out the slope, and the resultant where we are going to consider that is equal to, it depends upon the resultant. So that at R resultant is nothing but at point A, whether it is point B, depends upon where we are going to find out this resultant. At R is nothing but the, this is the formula which we use to find out this resultant. Here this f of x or rx is nothing but the shear force in the arch, and this f of I and normal thrust at x is the thrust in the arch, theta is the slope of the arch at axis point P, V is the shear force at P, she is the thrust at P, M is equal to bending moment at P. So these are the various parameters which are involved in this symmetrical parabolic arch. So as per the forces and also the various heights and rise, crown at point, and the length of the arch, slopes, these are all the parameters which we are going to understand in this particular scenario, that is the symmetrical parabolic arch. So according to the condition we are going to understand the what are the internal forces involved in this, how we are identifying those, and also find out the resultant forces are there. So these are the things are helpful for understanding. These things are helpful for finding the analysis of the arches as well as the at the time of the design considerations we are going to understand the various scenarios. So here what we understand one problem that is we are going to find out the bending moment, that is nothing but the BM, and radial shear RS, normal thrust NT. These are we are going to find out this practical one, this numerical one. So here from the length of the span is nothing but the total, that is equal to 12 meter. From at midpoint till crown, that is equal to 6, and the left side of the crown is 6 meters and right side of the crown parameter length is equal to 12 meters. Now from one side this uniformly distributed load is there, so that is equal to 10 kilonewton per meter. This is equal to 10 kilonewton per meter uniformly distributed. So the other side those point loads are there from crown to towards, this is A, this is B we consider as. So from crown to B, that is 2 meters, 10 kilonewtons point load is acting. After that, from 10 kilonewtons to again to one more 2 meters, 20 kilonewton load is acting. So this is the scenario we have. So for find out these bending moment and radial shear and normal thrust using the previous slides, understanding about that, how we are dealing these numerical one. So the step 1, we are going to find out the VA, VB and horizontal forces and vertical forces at that particular points. So as per the conditions, here we know the bending moment. So take bending moment with respect to B. So here we are consider this point B. Now bending moment with respect to B, that is nothing but this is the VA and this is VB, or sometimes it may use RB in some of the notations. Nothing wrong whether it is R, reaction at A or reaction at B, or vertical reaction at A and vertical reaction at B, and horizontal reaction at A and horizontal reaction at B. These are the parameters are there. Now this VA into till B, this length is equal to 12 meters. So VA, this various we have to understand. So from this, erasing all the things. Now clearly understand about the problem. So these are the support. This is at A, this is A, this is B. From this overall total length of this span is equal to 12 meters. 12 meters. Vertical reactions VA, vertical reaction at B is VB, horizontal reactions at B, horizontal reactions at A. These are the things we know. Now take the moments with respect to B. So now what are the moments we will get from here, from this side? So VA to this overall length, that is equal to VA into 12 plus horizontal reaction. From there is nothing is there from, so these are the two supports are at the same distance. So that way horizontal into minus, sorry 0. Next, from now what is there? So this is the load, this is the upward reaction. So now from here to here this is positive, that way we consider like this. Now here to here nothing is there, so that is also we consider as positive. There is no difference between these supports, it is a symmetrical one, that's why horizontal into 0 is there. Now coming to these loading is, it means downwards, this uniformly distributed load downwards, that way we are considered as minus, and this is uniformly distributed load. So that's why this 10 into, so how it is distances is there we will see, and this 16, this is half portion only it is going to act, and 6 by 2 plus 6 minus 20, this is from here to here we are considering. So 20 into 4 from here to here, and this is also there plus 20 into 2. So finally this is equal to 0. Calculate, done all the calculation, we will get vertical reaction at A, VA is equal to 55 kilonewtons. We may use any different types of scenarios also. So here 10 into this is equal to 16. How much distance it is there? Only 6 by 2 plus 6. That's why we are considering like this. And so what are the various reactions we are considering is this. So this 10 into, so finally this is equal to 55 kilonewtons. And similarly for the movements at the reaction at A. So here we are considering the movement at the reaction set. So from here to here, that is equal to minus VB into 12 plus HP into 0 plus 20 into 0 plus 20 into 8 plus 10 into 6 square by 2, that is equal to 0. Vertical reaction at B is equal to 45 kilonewtons. So this total load we are going to consider, that is equal to from the upward side. So here that is equal to 100, this is equal to 10 into, we will get, so 10 into 60 Like this also we may consider this total load. So that is equal to VA plus VB is equal to 55 plus 45, that is equal to 100 kilonewton. After that, we are understanding this horizontal reactions, how much these. So only LH side we are considering, and this left hand side and this is right hand side we are going to consider. So now VA only this left hand side means this portion is equal to 6 meters, this is equal to 6 meters. Total span is 12 meters. From here we are find out the horizontal reactions, that is equal to VA into 6 minus HA into 4, and this is the uniformly distributed load 10 into 6 square by 2. So this is the horizontal reaction we will get at A, that is equal to 37.5 kilonewton. This VA is equal to 55 kilonewton. This VB is equal to 45 kilonewton, and this horizontal reaction at right hand side is equal to the similar we will get, and from here we are finding this. So that is equal to minus VB into 6 plus HB into 4 minus 20 into 4 plus 20 into 2 is equal to 0. HB is equal to, after calculation, 37.5 kilonewtons. So this is 37.5 kilonewtons. So like this we are understanding the what are the shear forces and horizontal and vertical forces involved at the each and every point. Using these bending moment equations we are going to find out. So now move on to the bending moment and radial shear and normal thrust, thus according to the formula. So this YD is equal to, we know this YD is equal to 4R by L square into Lx minus x square. So here that we are going to find out that x is equal to 4. So now y at D is equal to 3.56 meters. That bending moment at D. So this bending moment at D is equal to VA into 4 minus HA into 3.56 minus, we know we are getting the height, that is equal to 3.56 minus 10 into 4 square by 2, that is equal to 6.5 kilonewton meter. And according to this we are going to find out this normal thrust, this bending moment at that particular point we are find out. Now this normal thrust we are going to find out the normal thrust, that is equal to V sin theta plus H cos theta is the formula, and at x we are finding, so that's why Vx is equal to Va minus 10 into 4, so that is equal to 15 kilonewtons. And here we are find out the theta is equal to 4R by L square L minus 2x, so that is equal to 25.46. Apply all these into this equation, finally we will get the 40.3 kilonewton as our normal thrust. In the radial shear, this radial shear also we know the formula Vx cos theta minus H sin theta, we know the all the parameters, and substitute all the parameter after calculations we will get this radial shear is equal to 2.58 kilonewton. Like this we are understanding this kind of symmetrical and the load conditions are not symmetrical, and these supports, whenever the supports and the parabolic is there, and here the load conditions is different at left hand side and right hand side, here the point load is there and the other side that is uniformly distributed load is there. So for these scenarios we are going to find out using these kind of, using the basic formulas we are find out the required height and exact point how the normal thrust and the radial shear how they reacted and how they acted, what are the values we are getting for those. So like this we are understanding this. Now in this and one more, these bending moment and radial shear and normal thrust 2 meter from right hand side. This is for left hand side we find out. Now from right hand side, from 2 meters from this right hand side we are going to find out this normal thrust and radial shear as well as the bending moment. So here this YE it is equal to 2.22 meters, Vx is equal to 25 kilonewton, bending moment at E is equal to, we are going to find out minus 6.75 kilonewton meter. Normal thrust, use the formula. So using that formula, this normal thrust NT is equal to Vx sin theta plus h cos theta. So finally we will get this theta is equal to 50.92. So and this normal thrust and radial shear, these are the values which we are going to substitute. Similarly, we will get this answer as like LHS. But the way of the formulas are same, but the way of approach, whenever we are understanding these various formulas, according the same formulas according to the various scenarios, here in the first condition we are applying from left hand side. In coming to this right hand side, now this right hand side the scenarios are different, but the same formula we are using. At that particular point we are going to find out this normal and radial stresses. So as per know about the conditions, then first we have to find out in whatever the problem it is. The first step which we are going to find out, that is equal to find out the unknown forces using the given conditions. Those are nothing but vertical force at points using the known load conditions, based on the known load conditions, and also the using the bending moment formulas, find out the vertical and horizontal reactions. Once know about these vertical and horizontal reactions according to the loading conditions, after that we know the formulas about the particular condition. So we know the formulas of the theta, normal thrust and radial shear, and the depth where we required this y. So these are the formulas, known formulas are there. We are going to apply into that. Finally we will get the whatever the required, we are going to find out using this procedure. So first know about the unknowns. So how we are finding, as per the loading conditions, we are going to find out the reactions of the given problem using the loading conditions. After that we are applying where we require that particular normal thrust or radial shear according to the using the respective formulas. So similarly, three hinged arch. So this three hinged circular arch, here this is the support and this is the support, three hinged generally at crown. So this is at crown, these are the points. So and this is A and this is B and this is C. So now given here the total length of the span is equal to 20 meters at middle, from each 10 meters. At from A to C the load conditions are acting, those are point loads at 50 kilonewtons and 75 kilonewtons from 2 meters and also the 4 meters. So 50 kilonewtons from A to, that is 2 meters respectively, and 4 meters at 75 kilonewtons respectively. So these are the things are there. First we are going to find out the vertical and horizontal reactions at points, end points, vertical reactions at A and B, horizontal reactions at A and B. Vertical reactions at A and B, horizontal reactions at A and B, find out the things first. So this is the step 1 which is involved in this. So find out the vertical reaction at A, horizontal reaction at A, vertical reaction at B, horizontal reaction at B. For this, take the bending moments at B. So here VA, this is the vertical reaction VA, vertical reaction at B, horizontal reaction at B, horizontal reaction at A. These are the involved. Now, vertical reaction VA into 20 minus 50. So remaining how these are the upward is positive. Here we consider this downward. This is nothing but the 50 multiplied by 18. Thus remaining is 18. Next, minus 75 multiplied by 16 is equal to 0. After calculations, vertical reaction at A is equal to 105 kilonewtons. Now VA is equal to 105 kilonewtons. Now taking the moments at A, the previously taking the moments at B, we know about the vertical reaction at A. Now taking the moments at A is equal to 0, that is equal to VB is equal to, so the total we know that is equal to VA plus VB. So no need to take moments and everything. VA plus VB is equal to, so the total reactions VA plus VB is equal to 50 plus 75, that is equal to 125. We know VA is equal to 105 plus VB is equal to 125. So that is equal to VB is equal to 220. No need to take every time this moments at A, moment at B. These kind of simple loading conditions like only points load inwards, this total load. Why? Because the total loads from the upward is equal to total load from the downward. That's only it will give these equilibrium conditions. Upwards and downwards, those are equal. Then only it will be in equilibrium condition. So for this equilibrium condition, based on this equilibrium condition, we are understanding this VA plus VB is equal to 105. Already we find out from taking moments from B, we know this VA is equal to 105. So from this VB is equal to 20 kilonewtons. Now find out the horizontal reactions at both the points, horizontal reactions at A, horizontal reactions at B. Now these horizontal reactions, we are going to find out these horizontal reactions. So according to these various points, we may use these conditions, know about the, based on the loading conditions, we will understand as per the experience and number of problems, then only we will get whether you choose this total load or taking moments from the point. So from here, from horizontal reaction at A, taking the moments, we are going to consider that is equal to VA into 10 minus HA into 6 minus 50 into 8 minus 75 into 6 is equal to 0. So here we are considered till this horizontal reaction. So HA is equal to 33.33 kilonewtons because these two are similar. So 33.33 kilonewtons at A. Horizontal reactions HB is equal to 33.33 kilonewton. Like this, we are the first step we are completed, that is vertical reactions at their respective points as well as the horizontal reactions at their respective points. Now we are going to find out this final Y at D. So where that this Y we are getting, that is equal to R. 2R minus R is equal to L square by 4. So here L is equal to 20 meters, R is equal to 6 meters. So finally YD is equal to, YD what we are getting, that is equal to 4.28 meters. From this we are going to find out the theta as per the equation. These are the things we will get. So and find out the bending moment at D. So that is equal to, according to that, VA into 4 minus 50 into 2 minus HA into YD. So that is equal to bending moment at D is equal to 117.35 kilonewton meter. So as per the formula, the normal thrust we are applying, so that is equal to 17.98 kilonewtons. Similarly, that radial shear is equal to minus 34.61. So like this, we are going to understand the what are the requirements using for the various conditions. So here, this is another condition. This is from 4 meters from the left hand side. In the other condition, 6 meters from the right hand side. So these are the new things which we are going to understand. At E, we are considering the point E. So YE is equal to 4.83. And moment at with respect to E, we are finding as per the known things. Find out the normal thrust using the formula. Apply what are the values are they already find out in previous till this. So now substitute those values into this. Finally, we will get this normal thrust as well as the normal shear as per the formula. The first step, find out the reactions. All the reactions. Find out the bending moment and normal thrust and radial shear and also the theta. As per the requirement, calculate the parameters. these are the basic steps which are involved in this kind of problems. Now move on to the two-hinged parabolic arch which has span of 15 meters and a point load which is acting only one side at a distance of 4 meters from left hand side. Find the bending moment. This BM is nothing but the bending moment. RS is nothing but the radial shear. NT is nothing but the normal thrust. And 3 meters from RHS since R is equal to 5 meters. So find out the vertical reactions and horizontal reactions. This is A. Consider this is at B. These are the two hinged. So find out the vertical reaction at A, vertical reaction at B, and this horizontal reaction at A and the horizontal reaction at B. This is the first step which we are going to find out. Take the moments at B. So this VA into 15 minus 20 into 11. This is nothing but 15 minus 4 is equal to 0 in detail. So this YA is equal to 15 minus 20 is nothing but 11. So this is the thing which we will get. So directly from VA. So VA total is equal to 15 meters. This is downwards. This is upwards. So downwards this is negative sign. 20 multiplied by 15 minus 4. From here to here only it is acting, or otherwise we may calculate. So VA into 15 is equal to 20 into 11. This VA is equal to, after calculation we will get this vertical reaction, that is equal to 14.67. From here to here this is 15. From here to here this is equal to 4 centimeters. And now find out the moment. So this is the single point load is there. No need to go to find out this in terms of moments at rate A. So like this also we may find out VA plus VB is equal to 20 kilonewtons. This is equal to 14.67 plus VB is equal to 20. So VB is equal to 5.30. So this VB is equal to 5.30. This is the another way. From whenever the point loads, uniformly distributed load, or one or two different types of loads are there, it is easy to find out the way. Otherwise, if more number of loads are involved, so we may choose these moments from both A and B. That is also okay, but as per the convenient, less time whenever we are using this total load condition, it gives the within the less time, as per the time constraint, it is within the less time we will find out the reaction at other side whenever the load conditions are less. So we may choose these moments with respect to A also. So we are find out like that also the vertical reaction at B. So now move on to the horizontal reactions and find out the what kind of, here we are going to find out the LHS. So various types of the hinged, this is the parabolic arch. We are going to find out the these bending moment, radial shear and normal thrust from 4 meters from LHS right hand side and 3 meters from the right hand side. So this is the left hand side and this is the right hand side, since R is equal to 5 meters. So there is no change in it. So now we are substituting these and find out these horizontal reactions, and finally we will get this value for these both conditions. Now find out the bending moment at required point. So it will consider from where we require, find out the bending moment at that particular point. For that, respect to normal thrust and radial shear, we are going to find out from whenever the LHS from 4 meters, similarly from 5 meters from the RHS. So according to that, we are going to find out the normal thrust and radius shear for their respective conditions. Now another type of 3-hinged arch of a span of 30 meters and a rise of 10 meters. So the arch carries UDL of 0.6 kilonewton per meter on the left half of the span. Only left half of the span the uniformly distributed load is acting. It also carries a concentrated loads of 1.6 and 1 kilometer at 5 meters and 10 meters from the right RT end. So this end. So determine the reactions at the support. if sketch not given. So here we draw the sketch. So now find out the vertical and horizontal reactions. We know as per the conditions we find out these horizontal and vertical reactions. As per the find out the moments. So from this we are going to find out the vertical and horizontal reactions as per previous. So find out this. So we know this VA plus VB is equal to 0.6 into 1.5 plus 1 plus 0.6, that is equal to 11.6. This is the total load involved in this vertical reaction. And now the moment at A, bending moment at A, that is nothing but the minus VB into 30 plus 1.6 into 25 plus 1 into 20 plus 0.6 into 15 multiplied by 7.5 is equal to 0. Final calculations, once we done this final calculation, we will get this VB is equal to 4.25. From this we are going to find out this VA also. So whenever the horizontal reactions we are going to find out at a moment at C. Here this is the 3-hinged arch. So here we are find out the moments at C also. So find out there also these horizontal and vertical reactions are similar. So finding the total reactions, we know this formula, find out these total reactions. So HA square plus VA square. So using this formula we find out the total reactions at A and find out the how much angle made it is there from these two, and also the find out the overall reactions at B and alpha at B. At that point we are going to find out using the conditions. And one more kind, the similarity is there in this 3-hinged parabolic arch of span 50 meters and rise of 15 carries a load of 10 kilonewton at a quarter span, that is the 1/4, it is nothing but the 1/4 of the span as shown in figure. Calculate the total reactions at the hinges. Here it is also 3-hinged arch. So A, B, C are the supports. We have 3 points. So here we know about this. So 3 points are there. Now find out the vertical reactions as well as the horizontal reactions using the moment with respect to A. That is nothing but the VB multiplied by 50 plus 10 into 12.5 is equal to 0. So here this is considered as negative and this downward is considered as positive. That's why this VB minus into overall is 50 plus this 10 into 12.5. So that is equal to gives the vertical reaction at B. Now the total reaction, so what vertical total reaction VA plus VB is equal to 0. This VA plus VB is equal to 10. So this VB is known. So VA plus 2.5 is equal to 10. Therefore the vertical reaction at A is equal to 7.5 kilonewton. Like that also we are going to consider this. VB is equal to 2.5 kilonewton. VA is equal to 7.5 kilonewton. This total vertical reaction is equal to 10. Like that we are find out the vertical reaction. Now move on to the horizontal reaction with respect to the moment with respect to C. So moment with respect to C, VB into 25 minus HP into 15 is equal to 0. Like this simply we are going to find out this. So because only one side reaction. So according to that we are going to draw this HA at A. This is the VA. HA is equal to 4.17. After finding this, find out this reaction RA. So like this we are going to understand this. From B, this is the reaction. These are the forces which we will get from horizontal B is equal to 4.17. Vertical B is equal to 4.25. This RB. This is the makes an angle alpha A. So find out the total reaction. We know the formula. Reactions at A are RA and alpha A is equal to tan inverse at vertical reaction at A by horizontal reaction at A, and alpha B is equal to tan inverse vertical reaction at B and horizontal reaction at B. So substitute all the values, we will get the final answers. Like this, we are going to understand these conditions. So this is till now what we understand whenever the supports are at the same condition. Now here, these supports are not at the same line. Here the support, one support at from here to here, that is different, and here to here, that is different. So this is the problem which we are going to understand in this. So now find out the horizontal and vertical reactions. So similarly we are applying, but here the difference is there. So this horizontal reaction is there, vertical reaction is there. These are the not symmetrical, so not at the same axis, the supports, so not at the same condition. So for this also we are finding the same vertical reactions. These vertical reactions from the total loads VA plus VB is equal to, we know, that is 180 and 180 plus this is equal to 10 and this meter is equal to 10. So plus 10 into 10, that is equal to 280 is the total vertical reaction. Now movements with respect to A is equal to 0. This VB into 24 plus HB into 2.4 plus 180 into 18 plus 10 into 10 into 5 is equal to 0. So finally we will get this equation. And after that, one more we are going to substitute, we will get this equation. Adding those two, finally we will get this HA and HB and these vertical reactions also. This vertical reaction at A, after the calculation, this vertical reaction A, 103 kilonewton. This vertical reaction is equal to 103 kilonewton. And the vertical reaction at B is equal to 177 kilonewton. This is equal to 177 kilonewtons. Those two are equal to 280. So this is satisfied. Now like this we are going to understand the various scenarios. So this is different kind of approach once we are understanding this. Now move on to the other kind of problem, that is a symmetrical three-hinged arch with a span, and this uniform, the loading condition is different. Here the uniformly distributed there and also with the point load. Find out these reactions for this. So vertical reaction at A, this is the three-hinged arch, vertical reaction at B, at this is point A, this is point B and this is point C. And horizontal reactions, horizontal reaction at A, horizontal reaction at B. So here we are going to find out the total VA plus VB is equal to, so 10 into 20 plus 40 plus 40, that is equal to 80 plus 200, 280. This is the total vertical load. So whenever we know, and these horizontal reactions HA is equal to HB. So the total vertical reaction at point A and B is equal to 280. The total horizontal reactions at A and at B is equal to similar. So we find out the movement with respect to A. According to that, we are going to identify the vertical reactions at both the points A and B. Similarly, for movement with respect to C gives the horizontal reactions. Those are equal. Now find out the bending moment. So we are considering these half whenever the X section. So this is the radial portion and this is the normal equation. So these two are perpendicular to each other. This horizontal and this is the dot vertical line. This horizontal and this is the normal, which is normal to the arch. And this is perpendicular to normal. That is nothing but the radial shear. So now find out this Y. We know the formula. According to formula, we are find out this Y. So after that, again using this Y, we are identifying the theta and also the normal thrust as well as the radial shear force. So like this we are understanding the various normal thrust and radial shear force conditions. Those two are perpendicular to each other, this normal shear and this radial shear force. Normal thrust as well as the radial shear both are under various conditions. We understand using those respective formulas we are finding the things. So these are the some of the references which helpful for better understanding about this concept. We will see in next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.